We have 56.8 grams of FeCl2, 14.0 grams of KNO3, and, oh Lord, we've got three things here, 40 grams of HCl are mixed. What is A, what is the limiting reactant? B, how many grams of each excess reactant are left over? Okay, so step one. Find the moles of product that could be produced from each reactant. And in this case, we have three reactants, so we're actually going to have three calculations. Okay. So, oh, and I haven't written the balanced equation yet. Well, that's kind of daft of me. Okay, here's our balanced equation. We have 3 FeCl2. We have KNO3, and we have 4 HCl goes to 3 FeCl3 plus NO plus 2H2O plus KCl. Good Lord, that is a complicated equation. Okay, so we'll leave that up for a second. Yeah, for sure. Yeah, take your time. It's all good. The other thing is to, you can always review it on video later, or if you want to, this is actually, if you have your Hebden, this is on page 133. Okie dokie. And what I'm going to do is I'm just going to write my grams that I start with under here. 56.8 grams. I'm starting with 14 grams, and I'm starting with 40 grams. So that actually makes it so that everything is in one place. Okay. So we are going to find moles of a product. Which product should we choose? Does it matter? Does it matter which product I choose? No, it absolutely does not. If somewhere in the question it said, how much water can be produced? Well, then I would have a tendency to use water. But, here it doesn't matter. So I'm just going to pick my first one. No good reason for that. Just because. Okay. So we want to find the moles of FeCl3 from reactant A, which is FeCl2. Okay. So we are starting with 56.8 grams of FeCl2. And step one, convert to moles. Moles FeCl2 from grams FeCl2. And that is 126.8. Thank you, Hebden, for providing that number for me. Okay. Step number 2, remember step number 2 is almost always convert from moles of substance A to moles of substance B. So we're going to go from moles of Fe, whoops, I want to cancel moles of FeCl2 and find moles of FeCl3. And we look at our equation, we have a 3 and a 3. So that means we have 3 and 3. We do our little calculation there. We get 56.8 divided by 126.8. And that gives us 0.4479 moles of FeCl3. Technically, if this was my final answer, I would have 3 sig figs, but I'm going to just leave 4 digits on the page because I'm going to press clear on my calculator now, and I want to have an extra digit there so that I don't end up with a rounding mistake later. Okay, so I'm just going to remember that I have 3 sig figs here, but I'm going to keep it on the page as 4 of them written down. Okay. Okay. We have a second reactant here. We want to find the moles of FeCl3, which choose the same product as before, but in this case, it's going to be from the KNO3. Okay. We have 14.0 grams KNO3. And we're always going to first, if we're not already in moles, we are going to convert into moles. So 1 mole KNO3 per 101.1 grams. That's the molar mass KNO3. Once you are in moles of substance A, you can convert into moles of substance B. So there's our substance A is the KNO3. Substance B is our iron chloride. Moles of FeCl3. And you always get those numbers from the balanced equation. We've got, oh look, there's nothing there, so it's just a 1. So 1 mole of KNO3 for 3 moles of FeCl3. All right, let's do that. 14 divided by 101.1 times 3 is 0.4154 moles FeCl3. Okay, and I'm really regretting having chosen this example because we have to do another calculation because we have 3 reactants. Oh boy. Okay. 10, 4, there we go. Okay, and reactant number 3 is our HCl. So we want to calculate the moles of product, FeCl3, from our third reactant, HCl. And we get, let's see, we have 40 grams of HCl to start. 40.0 grams HCl. Okay, and we want to cancel the grams of HCl, and we're going to go to moles HCl, because the first thing you always do if you're not in moles is go to moles. And the molar mass of HCl is 36.5 per 1 mole. Okay, once you're in moles, you can convert from moles of HCl into moles of your other substance, which is our product FeCl3. Okay, and our coefficients, well, we know that this one in front of the FeCl3 is a 3. Let's just go back and check our HCl. That is a 4. Okay, so now we have 40 divided by 36.5 times 3 divided by 4 is 0.8219 moles of FeCl3. Let's make sure I did that right. 40 divided by 36.5 times 3 divided by 4 is, yep, okay. Okay, so we have done step 1. Calculate the moles of product from each reactant. Here we are. Step 1 is done. Step 2, find the least amount of product. The least amount of product produced. So that would be, out of those 3, the least amount, this one is our smallest amount. So who is the limiting reactant? Yeah, absolutely. It is the KNO3. Okay. Now, if I was to have asked you, it doesn't ask this in the question, but if I said, how many moles of iron chloride are produced? Or if I said, this is part of the question that's not there. How many grams of FeCl3 are actually produced? I don't want to say actually because that's something different. Are produced in this reaction. If that's the case, how many grams of FeCl2 are produced? You go back and you say, I could not make 0.4479 grams because I would have run out of KNO3 before I made that much. I cannot make 0.8219 moles because I would have run out of the KNO3. I can only make 0.4154 moles. So you're going to take that number, and if you were asked how many grams you could form, you would just turn it into grams. So you would say 0.4154, 0.4154 grams of FeCl3, and then you would just convert that into, oh no, that was moles. Brain's going foggy. Oh dear. Moles of FeCl3, and you would find grams of FeCl3, and I don't know what that is. Let me see. Molar mass of FeCl2, 126.8 plus 35.5 is 162.3. Okay. 162.3 is the molar mass there. Times 0.4154 equals 67.419. Okay, but remember, if we go back here, 3 sig figs in my limiting reactant, and that gave me 3 sig figs here, even though I wrote 4, okay? And so down here, this in reality, even though I wrote 4, this number should only have 3 sig figs. And so our final answer would only have 3 sig figs. Okay? Do we want to go that final step and figure out how much excess reactant is left over? Yes. Okay. Let's do it then. So, there we go. Finding amount of reactant left over. You are always going to use this same subtraction. Okay? It's always going to be the amount of reactant at the start minus the amount of the reactant used. So it's always the stuff at the start minus the amount of stuff used. That will always be the same if you're finding the amount left over. So we have 2 excess reactants here, so we're going to do it for 2 things. So the amount in excess of, who was our first excess reactant? Well, KNO3 was our limiting reactant, so that means that our other 2 reactants, FeCl2 and HCl, are our excess reactants. Okay? FeCl2 is one of them, so we're going to find that. So that's going to be, and they asked us for mass here. So the leftover mass of FeCl2 is equal to the mass at the start, which would be given in the question. Okay, and I'm just going to copy it from Hebden, which I have in front of me. That was 56.8 grams that we started with. Now we need to subtract the amount used. This you are always going to calculate and you're going to calculate it from the limiting reactant, because how do we know how much gets used? Well, the limiting reactant gets all used up. How much of our excess reactant do we use in reacting with it? Whew, that was an exhausting sentence. Huh. So the mass of FeCl2 used to react with the limiting reactant, in this case, limiting reactant was KNO3. We're going to start with the KNO3, and we had 14 grams of that. That was given in the question, KNO3. We want to find the mass of FeCl2. So what we're going to be doing here is we're going to be going from grams of KNO3 to moles of KNO3 to moles of FeCl2 to grams of FeCl2. Okay. Whew. Okay, 14 grams of KNO3 times, let's cancel grams, KNO3, and find moles, KNO3. Molar mass is 101.1. Okay, now we need to do our mole ratio conversion from our balanced equation. And moles KNO3, we're converting it into moles of FeCl2. We can go back to our balanced reaction, which is way the heck up here, and see that the KNO3 has a 1 and the FeCl2 has a 3. KNO3 has a 1 and the FeCl2 has a 3. Okay. And finally, our last one here, we have, let's see. Oh, lost my train of thought there for a moment. We want to cancel moles of FeCl2 and find grams of FeCl2. So this is how much was going to get used up by that many grams of KNO3. So our molar mass of the FeCl2 is 128.6. 128.6. And we get 52.7. And that is the mass of FeCl2 used. And we can take that. Oh, so exhausting, these questions, I tell you. And we're taking the amount of reactant at the start and subtracting the amount used. The amount used was 52.7 grams used. Do our subtraction, and we get 4.1 grams. And because we're subtracting, we go to our first uncertain digit, which is in the 10th position. So our final answer will have 2 sig figs. Goodness me.